So guys, welcome to our second video. So in this video, remember what we discussed in our last video. We discussed about the arithmetics and comparison operators. So in this video, we are going to talk about Boolean operators, bitwise operators, compound operators. If you look at these Boolean operators, you see the symbols. This operator operates as a logic. This operates as logic state. Just like if you know how to use your AND gate, OR gate, and NOR gate in your normal electronics, analog electronics, this is how these Boolean operators works. So what it does is to compare the two inputs. Okay, just like the AND gate. So these are the symbol of the Boolean operator. Whenever you want to carry out a Boolean operator, this is the symbol. This is the symbol. Then this is the symbol of the bitwise operators. Okay, and this is the symbol of compound operators. So let me take it more further to explain it. So we will start with Boolean operators. So just like our AND gate, OR gate, and NOT gate in our normal day electronics circuit. So the way we know that AND gate, let me show you. Let me pull up the truth table of it here. So if you look at this place, you will see our, let me pull it over here. This is the AND gate. Okay, and we know that whenever the two inputs is 0, the output is 0, and when one of the inputs is 1 and the other one is 0, the output will still remain 0. Or the only time we will get an output is whenever the two inputs is high, which is 1, then we'll get an output. So that is what these Boolean operators work. That is how it works in the program. Okay, so let me show you. This here we just declare the normal variable with numbers. Okay, so this is a Boolean operator. You can use it as an if statement, just like setting a condition. So whenever you are using it inside if statement, this value here signifies as one of the inputs, while this one here signify as the second input. If you look at it, we use a bracket to separate it, and then comes the AND operator. Okay, in the middle we have the AND operator. So here, this one is one of the inputs. Let's say input A. This one is the other input B. But inside this one now, we are comparing two values, which is A and B. And we know that AND operators will only give us an output when the two inputs is true, when the two input is high or true. Okay, so let's check what this code is going to give us. In this first input now, look at the way I use bracket to differentiate it. This is the main bracket. Okay, this is the main bracket. See it here. This one is the main bracket. This one is the main bracket of the if statement. So inside this one, we say A greater than B. Let's check if A is greater than B. A is 10, while B is 20. We know that 10 is not greater than B. That means this input now is false, which is 0. It's not true. A is not greater than B. Then let's check this one now. Let's check this one. C is 30. B is 20. So is 30 less than B, which is what? False. Is not true. 30 is not less than B. 30 can never be less than 20, because we are checking these two inputs. The C means 30, the B means 20. So is 30 less than B? No, which is false. So these two inputs is not true. That means we are going to get whenever we want to try to print it on the serial monitor, we are going to get a false. It's going to print false because these two input is not true. Okay, but let's assume in now that we put C here. Let's say that we put C here. This is C. Okay, let me use a capital letter. This is C, and this one is A. So we have A here. So let's check the condition now. Is C greater than B? C is 30. Yes, 30 is greater than 20, which means this one is true. Okay, Then we still have the AND operator here, the symbol. See the symbol here. Okay, then let's take this second one now. Is A less than B? A is 10. Yes, 10 is less than 20. That means this one is true. So whenever we are comparing these two things, that means we are going to get a true if we try to print it in the serial monitor. I'm not going to do that now. The reason why is that in our upcoming videos, when we will start doing projects, you will be coming across all these operators, operators that I'm explaining now. So I'm not going to go on and simulate it now, but I'm just trying to clarify it. So if you look at it now, this one is true, this one is true, this one is true. That means we have fulfilled the truth table of the AND gate. Okay, that means these two input is true. That means we are going to get a true output, right? So let's assume now we are making use of the OR gate. This is the OR gate and this is the symbol. So let's delete this one and use the symbol of OR gate. Okay, so let's use OR gate. This is the symbol of OR gate, and let's check the truth table of OR gate and see what OR gate is saying. This is the truth table of OR gate, and the truth table of OR gate is that if the two input is false, the output will be false. If one of the input is true, we are going to get a true output. Okay, so either A input or B input, anyone that is true, we are going to get a true output. So let's check it by using this method, using this if statement. So let's say that let me change the value again. So let me change the value to C. Okay, so let's compare it. Is C greater than B? Yes, 30 is greater than 20. That means this input here now is true. Let's check the other input. Remember the OR input here. This is the symbol. We are comparing the two inputs. So let's check this input now. Is C, which is 30, less than B? No. That means this input here is false because 30 is not less than 20. That means this one is false. But because we are using an OR gate, we are using an OR symbol, we are going to get a true output because the OR truth table says that either one of the input is either true or false. Okay, that's what the truth table of OR gate says. So we are going to get a true output because one of the input is true. Okay, so if you don't want to use the if statement, you can also use it like this. Just make sure you define the value that you store it. Just define the variable that you are going to store your answer. Okay, which is D. I declared a variable D here. So if I don't want to use if statement, I can just do my normal mathematics. Okay, by just using D and assign it to this thing. And whenever I use print F, I will just put D inside this bracket and it's going to print whatever. And bear it in mind, if this thing now is false, this two input here is false, what the output that is going to print out is going to be 0 because the thing is false. Is going to return 0 for me if you are using this method. Okay, but the method we are using here is the if statement. That's the method we are using because we normally use it to achieve some certain things in our electronics or whenever we want to trigger something. Okay, but if you want to do normal mathematics, you can just use this method. It's left for you to decide. So in terms of OR gate, whenever we want to use OR gate, how do we use OR gate? We don't need to compare these two things. How we use OR gate is that I'm going to delete this thing. And you know what OR gate means. OR gate just inverts. So if this thing is true, OR gate is going to invert it. If it is false, OR gate is going to invert it. So what I'm going to do is just to use the symbol of the OR gate, which is this. So mind the way I use it. The symbol comes first before whatever you are comparing it with. So this one, and you know the OR gate has one input. It doesn't have two inputs. That's why we have to remove one of the other input, use only one, because OR gate only makes use of one input. So let's check this condition now. If C less than B, C is 30, so 30 is not less than 20. That means this thing is false, but we are going to get a true output because we are using OR gate. OR gate is going to invert it. Okay, sorry, not all gate, not gate, sorry, I made a mistake, not all gate, not gate. Let's see the truth table of not gate. So this is the truth table of not gate. So when the input is 0, the output is 1, and when the output is 1, the input when the input is 1, the output is 0. So that is what we are doing here. Here is false. Here 30 is not less than 20. That means this thing is false. But because we are using not gate symbol, it's going to invert this thing to be true. So that means if we print this thing in the serial monitor, we are going to get true because we use not gate to invert it. So assuming we not use not gate, we are going to get false because this thing is false. But because we use not gate is going to invert that false. That means that false we are getting is normally 0. Okay, it's going to invert it to 1, making this thing to be true. So that is it all about Boolean operators. Okay, this is all about Boolean operators. I hope you understand it. So you can use this method within, and you know that we have the AND gate, OR gate, and NOT gate in Boolean operators in programming. So if you want to make use of this NOT gate, AND gate, and OR gate using this method, you can also use it. I hope you understand the Boolean operators.